Yes, go ahead. Okay, so let's move on to pyramids and cones and spheres. So our plan for today, when we finish talking about spheres, 'cause I didn't quite finish that last time. I did actually get to most of it with the E period, but I'll do it with you guys here. And then we're gonna do I think problems one, two, and three. And I have to double check Schoology. Because I think one of the homework assignments actually covers some of these problems. I don't want to do all these problems. Yeah, I'm not gonna do three and four. So I'll skip three and four today, because that just will be, so let me make sure that's right. Of 12. Yeah. So I'll skip three and four. But yeah, we'll do like one, two, five. It's actually quite a lot. So we'll see how far we get. I mean, I highly doubt we get all this today. Anyhow, let's talk about spheres. So we talked about sphere is 4 pi r squared, and just kind of just go with that. Like, there's not really a derivation I'll do with that. Just the sphere is round everywhere. It's not flat, obviously, just like the bubbles you guys were playing with, right? So there's no like lateral area to worry about. It's just really just a total area, and it's 4 pi r squared. So just go with that.
The total area and surface area will always be the same.
Correct. Yeah, if you're told to find the
Okay, yeah.
surface area, if you're told to find the surface area, it actually is implied to do total area, right?
Yeah.
That's the implication. Yeah. So here's the deal with a cylinder, and I kind of rushed this the other day, so let's talk about this again. So I'm going to draw a sphere or a bubble, and let's draw a cylinder on page 3. I'm going to draw a cone. Okay, I'm going to draw the radius. Draw the radius and draw the radius. Let's assume all these radii, that's plural for radius, are all equal. Okay. So every single shape has the same radius. So R, 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 they're all the same. Also assume the same height. So here's my height. Here's my height. I'll call it capital H for height. Now, sphere is kind of weird, but I'll call this a height. But what is that really? What do we really call that when you connect end to end of a not circumference, diameter, right? Diameter, right? So this is just like the diameter, right? And the diameter is how many times the radius? Twice. Good. So H equals 2R. How do you know? Because the diameter will equal the height. That's how I know. Because we did it on purpose, right? You're told to do that on purpose to consider that. Now, this is the part I wish we had a demonstration to do, but I don't really have it. But let's assume that those bubbles you guys are making, right? Let's say you're able to fill that bubble with water, and that's kind of weird. But let's say you did that, right? And the cylinders that we were playing with the other day, right? Um, I'm gonna pour the sphere into the cylinder. I'm gonna also pour the cone into the cylinder, right? Now, if you guys remember, how many times I have to fill up the cone to fill up the cylinder? It's 3 times, right? We know that. So here's what's gonna happen. If I were to pour water into this, right, it would only fill up 1/3 of the way. Now, if I were to fill up a sphere full of water and also pour into it, it's gonna fill it up after the cone. So if I pour the cone in, it goes to 1/3 of the water height, water level, right? If I pour the sphere in, it's gonna fill it all the way up. So just trust me on that. So we don't have this demonstration, unfortunately, but he discovered that cylinder can be filled perfectly by combining the full volume of the cone and the full volume of the sphere. So the sphere, if the sphere is all filled up, plus the cone, if the cone is all filled up, it's going to equal the cylinder. Now, if we do some math here, what's the volume of the cylinder? Do you guys remember? Pi r squared. Why is it pi r squared h for the volume of the cylinder?
It's just like finding a circle and then
Yeah, what's your base? A circle times the height. It's just a prism. A cylinder is just a prism. It's a base times the height. And what was the volume of a cone? We said it was 1/3 BH, right? So I'll put a little question mark here. What do you think the sphere has to be? And by the way, B is pi r squared. It's 2/3. Or yeah, I'm going to put pi r squared h. Um, so yeah, I would expect the sphere to be 2/3 pi r squared h. Because you're told that. You're told if you fill up the sphere full of water, fill up the cone full of water, pour into the cylinder, it's going to fill up the cylinder perfectly. It'll be totally full. And again, the cylinder is pi r squared h, the base times the height. The cone, we already saw that with the demonstration yesterday, 1/3 pi r squared h. So naturally, the sphere has to be what's left over, 2/3 pi r squared h. Does that make sense? Now, what does h equal again? Or 2r? So if I do 2/3 pi r squared times 2r, what do you get? 4/3 pi r cubed. And that's the volume of the sphere. That's where it comes from. So it's 4/3 pi r cubed. Of course, I'll give that to you. You don't have to memorize it. But if you were to try to understand where it comes from this situation that you take a sphere, take a cone, fill it up, pour it to the cylinder, fills up perfectly. So naturally, the sphere has to be 2/3 pi r cubed. Sorry, 2/3 pi r squared h. And because h is 2r, if you set it up this way, this is the only way it's going to work. It's set up this way for the sphere and the cone to fill up the cylinder. Then substitute for h 2r, and you should get it. Yeah, Faith.
Why did you do the formula like that formula?
For which one? Which one?
Is that
Yeah, that's the volume of the sphere. After I subtracted this with this, because in order for that to work, what are you going to add to 1/3 to get to? No, I did subtract. I did pi r squared h minus 1/3 pi r squared h. I did subtract. I subtracted this with this
you get 2/3
to get 2/3 pi r squared h. Correct.
or pi off. Well,
Oh, over here, you mean?
Yeah.
Oh, I just substituted. H is 2r. Because we established that earlier on in part A. Right? Because H is 2r. Right? Because H is 2r after I substitute, and then I just clean it up. That's all. Yep. So that's the formula. Again, it's 4/3 pi r cubed. Easy peasy. 4/3 pi r cubed. And of course, that's 4 pi r squared. Okay, so now I think we're ready to do some practice problems. Bless you. Okay, as I said, I'm going to do 1 and 2 with you guys. 3, 4 will be homework for another time. Not the one that's due Thursday, but the one due after the weekend. And then after I do 1 and 2, I'll have you guys just work on the rest of the problems and see how it goes. And if you guys are kind of tapped out, we'll tap out and get some do the other homework or play bubbles. So, all right. So let's look at this one here. So a regular square pyramid has a base edge of 6 and a lateral edge of 5. Find all those things. Okay. So it's saying that the base edge is 6. So base and edge, right? Lateral faces, that's going to be 5. By the way, how do I know that? How do I know that BM and MD are H3? How can I say it with confidence? It's a square, and M represents what? The midpoint, yeah. And it should be the midpoint because it's coming straight from O, and isn't O in the middle? Yeah, so that makes sense. Okay, so now this is where it gets a little bit crazy. So this side, this is going to be called L, the slant height. So if I redraw one of the triangles, it's so important that you label appropriately. VMD. How long is VD again? according to the solid.5. How long is MD? So how long will VM is gonna be the slant height? How long is that gonna be? What do you think L equals, guys? Good. It's 4. And that's just Pythagorean theorem, right? So is everyone okay with that? Cool with that? Okay, good. So that's 4. So now I can just replace that 4. How long is OM? 3, right? So we'll call this the inside triangle diagram because it is inside the diagram, right? And this is VOM. How long is VO? Nope, because 4 is not hypotenuse. Careful. I know you want to say 5 because we always see that together. But let's say it calls X. X squared plus 3 squared equals what squared? So what does X squared equal? You guys know this. X squared plus 3 squared equals 4. I'm doing Pythagorean theorem, right? No. What's 4 squared? I know, slaying the day. 4 squared is what? No, 4 squared, guys. 16. Good. Good. All right. Now I know, guys. So 3 squared is 9. So 7. Good. Good. So X is root 7. Good. Okay. It's getting a little worried. X is root 7. So ask me the height. The height's root 7. Now it's kind of a funky value. But that's the height of the trapezoid or the altitude. Sorry, the trapezoid. Sorry, the pyramid. I don't want to say trapezoid. It's crazy. I'm talking crazy. Okay. That's the altitude of the pyramid. Okay. Now P is going to be the perimeter of the base. What's my perimeter of the base? So 24. This is the area of the base. What's the area of the base going to be? 36. Okay. I didn't quite follow all these different diagrams. I mean, sure you can redraw the base. The lateral face diagram, by the way, is right over here. Oh yeah. Oh yeah. That's where we're gonna practice this.
Not quiz.
Not on the quiz, no. No. But a test it. No, Thursday's just prisms. I already told you it's just gonna be, it'll be like a triangular prism or something like that. Like I give you the dimensions, find me the volume or surface area, or then I'll give you another one, but I'll tell you what the volume or surface area is, and you gotta find a dimension, like a radius or height, or a side length, whatever. If it's a cylinder, of course it's a radius. Anyhow, okay. So now we have to find all these things, right? So the lateral area, if you guys remember, was 1/2 PL. That's because you're doing the perimeter times the slant height, but you're doing it 4 times. So it's essentially doing 1/2 times base times height for each triangle. But a way you can consolidate the whole process is consider all the perimeters, right? Like all the side lengths. Sorry, consider the perimeter 6, 6, 6, 6, and then the slant height's 4. Like one of these triangles. Let's just actually just talk it out. So one of these triangles here. Let's look at VBD, right? What's the length of BD? 6. And what's the height of that triangle? Which we call the slant height because slanted. 4. What's the area of that triangle? How many triangles do I have? So 48, right? 12 times 4 is 48. So I know the answer is 48, but if you use this formula instead, the perimeter is 24, the slant height's 4. If you multiply it out, what do you get? 48. So it's still the same thing. You just can use this formula to consolidate the whole process. The total area, half of 24 is 12, and 12 times 4 is 48. The total area is the lateral area plus the base. Yeah, I only have one base, right? My lateral area is 48. What's the area of my base again? 36, so you get 84. So once you get the lateral area, it's kind of smooth sailing, right? Because like, cool, I got my perimeter. Let's work it all out. But you really need to figure out these dimensions as we put off to the side here, because it just makes the rest of the problem very smooth. And then lastly, for the volume, that's 1/3, because we remember we filled 1/3 of the pyramids, fill up a prism. 1/3 BH. 1/3, what's your B value? It's going to be 36. What's your H value? It's √7. That's very funny. So you get 12 √7.
Wait, why is it one?
Remember we did that when we filled it up when Kira kept like spilling. Actually, no, Zoe did a good job. Kira did the cones. When Zoe was filling up the pyramids, you have to fill the pyramid 3 times to fill up the prism. That's why it's 1/3. Because the prism's BH. So we see that the pyramid's a fraction of the prism. Because they're essentially actually just so you can visualize it. It doesn't matter what the base is, this is pentagons, it doesn't matter. But I do know these align perfectly. So I need 3 of these to fill this. They have the same height, clearly, right? They have the same base, clearly. But it's pretty clear this has more space than this. How much more space? 3 times many. That's all.
Basically,
And I'll give you the formula, by the way. I'll give it to you. You don't have to memorize it. I'll give all of them. Everything. Everything. Yeah, I don't care. But, it's just good to understand why it works. But once you know the formulas, then it's just more of a matter of executing. Yeah, go. Oh, yeah, of course, yeah. So those are your answers. 48 for the lateral area, 84 for total area, and 12 √7 for volume. So yeah, it's pretty involved. We obviously dedicated a whole page to that problem. All right. Obviously you're gonna squeeze some stuff in here. So I'm gonna do 2 with you guys. 3, 4 don't do. 3, 4 will be homework for later in the week. But I will have you start number 5 after I finish number 2. And just kind of see, and then maybe we'll do 5, 6, 8, and maybe 3 problems here. So maybe we'll just do like evens or odds. Maybe odds. Yeah, just because we'll do odds. So I'll do 1. So I'll do 2. We'll skip 3, 4. And then after just do the odds. You do 5, 7, 9, 1, 3, 5, 7. So a lot of problems, but we'll see how it goes. All right, so for number 2. So again, square pyramid, base edge is 8, height's 4. Okay, so we kind of just did this already, right? So it's kind of like drawing a tent. If you think about it, right? Not by best pyramid. The more I think about it, there's a famous city that has structures of these shapes. You know what city I'm talking about? What city am I talking about?
this,
Well, Egypt for sure. Egypt for sure. But which one also has a sphere too? Las Vegas. So the sphere, which opened a few years ago, is very popular now. So it looks like really cool. Love to see it. And of course, there's a hotel called Luxor, which is shaped like a pyramid. So, and of course, all the other hotels are more like prisms. But anyhow, I don't think any hotels are shaped like a cylinder necessarily. But anyhow, or a cone. Um, so this is 8, 8, and the height's 4. Okay, that's such a crappy drawing. I did such a terrible job with this. Oh my gosh, this is awful. It's all right. Okay, it's not to scale, mind you, but how long is that side that I just drew an arrow to? So now you have a triangle like this, right? 4, 4. And this blue line that's slanted, what do we call that again? That blue line that's slanted? L, or slant height. Yeah, correct. So we definitely want the height, which we know is 4. We definitely want the slant height, which I'm going to find in a moment. We definitely want the perimeter, and we definitely want the base. Well, the base is easy. What's the area of the base? That's easy. 64, right? That's easy. What's the perimeter? That's easy too. 32. Okay, we're almost home free. So L is going to be a little bit crazy. What do you guys think? It's root 32 because you're doing 16 plus 16 and you're rooting it. So I totally agree, root 32. Can that be simplified? Is there a perfect square that's a factor of 32? So 4 root 2. Yeah, probably a little easier to write like that. Just comes out a little cleaner. So 4 root 2. Okay, so let's find our LA, our TA, and our V. The V is easy. 1/3. What's the area of the base again? And the height, of course, is 4. So if you clean it up, you can use a calculator. It's 256 over 3. Cubic centimeters, mind you. That's not divisible because 64 and 4 are not factors, or sorry, not multiples of 3. So it's not divisible. Don't worry about it. Lateral area is 1/2 PL. So 1/2 times the perimeter times the L, which is 4 root 2. Let me make that 2 a little better on the fraction. Sorry about that.
4, height.
It is because he said so. Yeah. So that winds up becoming 64 root 2.
316.
Correct. Right. And you could use a calculator, of course, right? That's square centimeters. The total area is LA plus the B. LA 64 root 2. And of course, the B is 64. And that's square centimeters. Yeah, sorry, 64 root 2. That's been covered. There we go. Okay, we're good? Okay, skip 3 and 4. Go and give 5 a shot. Now it's a triangular pyramid. I mean, it looks like this. And it's regular. So it's going to be equilateral triangle on the bottom. Let me do these dashes. That's going to be. So when you do three-dimensional diagrams, it really helps to do dashes like that. Can kind of play your head with a little bit, like the initiative is going in or out of the page. The base perimeter is 12. So how long is each side of the base? Good. Base edge is 4. So 4, 4, and 4. The slant height's 9. So it means that if you look at one of these triangles here, if that's 4, that's 9. Ugh, this is getting a little messy.
Nine the height.
Height of the triangle. Really, I really don't like this problem, but we're gonna do it. It's just hard to visualize. That's 9. I think that's 2. Yeah, that's correct. Remember, this is always half. Actually, is that right? No, no, hold on. I'm tripping. Give me a sec here. Center's here. That's the height. And then you have triangle looks like this. That's a height. That's 9. Yeah. Ugh, this is tricky.
Right.
It's not, it's not 2. Here's the reason why. This is your base, right? That's 4, 4, and 4. Here's the middle of that triangle. So let's go a little highlighter here. Let's go different shade of blue. This is the same as this, or the same as this. Those are all the same. Would you guys agree visually? Different vantage points. That's a three-dimensional vantage point, right? That's actually looking at it from a planar vantage point, like, oh, here. And of course, I do it out like that too. It's not 2.
On a test, will you just like give us the diagram of this? It's super hard to draw.
I gotta talk to Mr. Davis about that. Let me get back to you on that. So here's the deal. That's 2, and that's 2. What kind of triangle is happening here? Also equilateral. That's 30 degrees. That's 30 degrees. And that right there is 60 degrees. So if I focus on that little triangle right there, where that's 2. Oh, you gotta be kidding me. And that's 60 degrees. We'll call this X. What would X equal? You could use trig if you want, or you gotta use your ratios. Remember the ratios? X, 2x, and x root 3. Remember that? The 2 lines up with which side? If it's opposite 60. Correct. So is X equal 2 root 3. So it comes 2 root 3 over 3. So the height, if I were to solve it, 81 equals h squared plus, that's 4, 3 is 12 over 9, which is 4/3. Is that right? Yeah. So your height's going to be, wherever that is. We'll do it as a decimal because I'm not going to do it as an exact form. So somehow a calculator I could, no, I could get one. Oh, goodness, gravy. 81 minus 12 ninths. Yeah, you get 79.67. Oh, I got square root it. Hold on. After I square, you get 8.93. Okay, so that's my height, 8.93. Now I can get everything else, right? The lateral area is easy. That's 1/2 PL. My perimeter is 12, so 1/2. My slant height is 9, so that's 54 square centimeters. My base, because it's a triangle, and because now I know I'm doing an equal triangle. Um, if that's 4, that's 4, that's 2, that's 2√3. Yeah, that should be 2√3. Um, yeah, so that, yeah, because that's, make sure I'm doing all this correctly. Hold on. I feel like something is off a little bit here. X√3 is 2. It's 2. It's 4. Hold on, something just seems off to me. 2√3. No, that's right. No, we got it. Yeah, it's just gonna be a wonky. Yeah. So anyhow, the area of the triangle is gonna be 4√3. So our total area is gonna be 54 plus 4√3. That's because your base is 4 and your height's 2√3. You gotta take half of that. And the volume, which is 1/3 times the base, which of course is 4√3 times 8.93.
Is he on the test?
I don't know. This is a little too crazy, I think. We want to make sure the numbers work. I didn't like how these numbers worked out. I'm a little disappointed because it is hard to find that little sliver there, but you had to. If it was a square, it'd be easier, I would say. Sorry, the what? Sorry, this one here, because I needed that to help me find the height of the pyramid. That's what. No, because I had the slant height. It's way the information is all given. If I multiply that out times 4√3 times 4√3 divided by 3, yeah, you get 20.6 for volume, all surrounded one decimal place, cubic centimeters. So, ugh, that was not a fun one. I'll freeze the screen. So, why don't you guys go ahead and go about the rest of the problems? I mean, just the odds. So, try 7 and try 9. See how it goes. Let's check in a few minutes. Let's try 7 and 9, and then if we have time, we'll move on to spheres. Just try 7 and 9 right now. Skip 5 and 6. Sorry, skip 6 and 8. And I'll leave this frozen right here so you guys can. I'm going to work out 7 right now. We'll check in a few minutes. So it's a cone, raised to 6, slant height 12. Okay, this one's way more tolerable. That last problem was really crappy. I did not enjoy that one. Can I move away from the screen? Okay, that's how it should look, right? Should look like that. I know. Can work it out now. Would you want to just find the height, find the circumference of the base or the perimeter of the base, find the area of the base, and then everything else should be and just want volume this time. So that's lovely. They just want volume. Yeah, this comes out really nice and clean. I think you guys probably appreciate I give you this as a test question. All right, let me know when you guys are ready. See you 7. Yeah, we were cool at 5. It was really nasty.
Wait,
No. That was just so when we deliberately had the sphere have the same height as the cylinder and the same radius as the cylinder, and likewise with the cone. That was if we had deliberately done that, you would see when you do the comparisons that the sphere has to be the volume that we get.
wait, so
Yeah, good.
like,
What do you guys get for the height? Good. What do you get for the circumference? What do you get for the base? Area of the base. 36 pi. Good. Okay. And what's 4 volume? 1/3 base times height. So there we go. Just put it all together. You guys should get an answer for very soon.
why are we?
We didn't actually. You're right. We didn't. You know, that was just by habit. Actually, you're 100% correct. We didn't need to. That's if I had to find surface area or lateral area. I had to. Yeah.
Do we leave it?
Yes. In this case, I would. In terms of pi. If you have an answer? Oh, okay. No worries. Anyone have an answer? 96 pi. Yeah. Good. Good work. Awesome. Yeah. 96 pi. I think that's a reasonable test problem. Because I mean, testing on, Pythagorean theorem, of course, and, just figuring out what to do and drawing it. So, okay. I think that's a reasonable problem. All right. I'll freeze the screen. Take a look at 9. Now for 9, you have a metal cylinder, you're melting it, and you have those dimensions, and you're recasting as a cone with the radius of 8. Find the height of the cone. So what this means, if you're melting it, what's true about the volume of both the cylinder and the cone? They're the same. Yep. So we can do that. So let's go ahead and do that right now. That's, I think, a good. Let's make sure numbers work out nice, but I think it's a good test problem. Correct. And use that for the cone. Correct. Because you're melting it down. Yeah, I thought it was a really good test question. For those who follow the World Cup for men's, I know Mr. Davidson's daughter, she played in the World Cup for women's. But for men, do you guys know how the trophy looks for the men's World Cup trophy? Is anyone familiar how it looks?
That's soccer ball.
Yes, there's like a sphere and there's like a person, I think, holding or something like that. So I think back in the 70s, I think when Brazil won one of them, the trophy was stolen and it's made of pure gold. And it was melted. And that's how they were able to, I guess, get away with it. So no one could figure out where that trophy went. And it was recast as something else. But that might be kind of cool test question. I don't know. Just but you have to give the dimensions, obviously. But that happened in real life, so that'd be kind of interesting.
Like that couldn't happen now. Like all
No security. Yeah.
people
Oh yeah. Well, yeah.
like even if they like were able to like melt it down and like break it apart, like we'll be able to like track it on the internet.
I think so. Yeah. Yeah.
Crazy.
But yeah.
Yeah.
I don't know. I think so.
How much does that cost? I'll make that.
Actually, let's see what ChatGPT or Google Gemini tells us. Value of World Cup trophy. It's worth about $250,000. So 250 grand. Um, However, due to the cost, it costs 250,000 to make. Its market value is $20 million. It's the most valuable sporting trophy in the world. Here's how it looks.
Do you follow men's soccer?
Not as much as I do other sports.
Why?
Didn't grow up. Just there wasn't much soccer to watch on TV as a kid. Yeah, it's a pretty beautiful trophy. Yeah, that's a very famous player right there, Diego Maradona. But World Cup I get into. World Cup's pretty. They'll be happy in the summer. America, the underdogs. I kind of like those like small African countries, like they just no one knows who they are, and like Ivory Coast or Cameroon, like that'd be kind of fun. Typically Middle Eastern teams, I'll like Jordan. My mom's family's from Jordan, so I'll probably root for them, but they don't stand a chance. Um, I have cousins who are half Brazilian, so sometimes I just root for Brazil, and they love soccer. So I don't. The European powerhouses like they win all the time. Like I'd rather have someone else win. Anyhow, um, so let's go back to the problem. So you should be getting 272 pi, right? And then the volume of the cone is this formula, right? 1/3 pi r squared h. So 272 pi equals 1/3 pi. And what's the radius of the cone? 8, right? Okay. And so now we have to work that out, whatever that is, and solve for the height. The pi's will cancel, fortunately. Yeah, good. Sure, of course. Yeah. By 64 times 3. You guys have a value for the height? 12.75, right? And make sure it seems reasonable. If you get like a super tiny value, that'd be weird, or super big value would be weird. So make sure it seems reasonable. 12.75 seems reasonable. So yeah, that's a reasonable problem. I like that. Problem 9, it's good. Okay, we're humming along. Okay, let's look at 1 and 3. Oh, 1's too easy.
Are we still doing one?
Yeah, we'll do 1 and 3.
Or what we have to do this
12.75 for number 9.
64 times 130.
I want to do that. I would do 272 times 3 first, and then divide by 64. Yeah, just avoid any nasty fraction decimals along the way. Yeah, we'll do 1 and 3 now on the next page. That should be pretty fast. And we do 5 to 7. The other problems we can save for Thursday. What do you get for the surface area? For number 1. And the volume. You can leave them in exact form.
Wait, how do you do it first? Here again.
Oh, just 4 pi r squared for area and 4/3 pi r cubed for volume. You just plug it into a form. That's all you're doing. Yeah, I'll give them to 4 pi r squared and 4/3 pi r cubed. I mean, we derived the one for volume. Area, I kind of just told you what it was. Yeah, 16 pi, 32 pi over 3. And for number 3, your R should be 20. You set it equal to the volume formula solve. Pi's cancel, 3's cancel. R cube equals 8,000. 8,000 cube rooted should be 20. That's 20 units. Okay, good there.
Does it matter how high on the top or the bottom side of the
You never want the bottom unless if it really has to be. I mean, it usually should be up top, but if it's to the sides, the same thing. Like if you had like 4 pi over 3, those are the same thing, just so you know. Because if you think about it, that's like saying pi over 1. You can make a fraction and multiply to get back to 4 pi over 3. It doesn't interchangeable, it doesn't matter. Don't put on the bottom, it's a totally different thing, right? You don't want that. Okay, 1 and 3 are okay? Yeah. That equal 4/3 power cubed. Right. Correct. Right. Yep. All right, let's take a look at 5. Naomi wants to give her teacher a spherical candle. That's okay. Yeah, I guess they're spherical candles. For her birthday, these candles are cylinder-like. The candle's a radius of 6. She wants to gift wrap the candle in a cylindrical container that fits just right around, so it's nice and snug. What is the volume of the cylinder container? So which one's bigger, the cylinder or the sphere? Of course, right? Yeah, because you gotta fit the candle inside of it, right? And the sphere is gonna be nice and snug. I have an opportunity to do some shapes here, maybe.
Does that mean it would be the same size?
Yes, a lot. There's gonna be a lot of crap. Whoa. Yeah, it's gonna be kind of like that. So it fits nice and snug. So what's the radius of the candle again? 6. And volume of a cylinder is pi r squared h. What's the height of this container going to be? Yeah, 12. Because notice how if it's nice and snug, 6 and 6, you get 12. So you get 432 pi. Okay, and the last one, number 7. Yeah, and it was to play tennis. This is how this is for a racquetball, I guess. But yeah, it's also pretty straightforward. If the radius of each racquetball is 1.125, so that's 1.125, 1.125. What's my height going to be? What was that? 4.5 because you multiply by 4, right? Good. So yeah, pretty straightforward again. Pi r squared h pi times 1.125. Why did I keep trying an extra one? 125 squared times 4.5. And whatever that is, 5.7 pi. Or I'll just multiply the pi out. Let's get a decimal. We'll multiply the pi out. So you get 17.9. Okay. And that's cubic inches. Okay, it's quite a lot of problems. Yeah, there's no way we could get all this done today. That's just way too much. So we're gonna do more of this, and then I'm gonna talk about the project with you guys. I'm still thinking about what I want to do. Either it's gonna involve food or a swimming pool. I don't know. Food's more fun, but if I get some time to go to a store and I don't know, if I get more creative tonight, I'll let you know. You'll know the project is on Thursday. So, all right, we're all done. Homework is just homework 28. You guys already have a handout of it, so all's good, and we're set.